Day 281 of doing a LeetCode problem every day until I get a job. All right, y'all, we're back again another day, another LeetCode problem where we're doing daily LeetCode problems. And today we have question number 69, square root of x. The difficulty level is easy, but don't even worry because we're going to keep the solution as simple and easy to understand as well. But before we get started, y'all, don't forget to like, comment, and subscribe. And if you need any new Apple AirPods, go ahead and check out that link in the description and go ahead and grab you some. Now, with that being said, let's get into the question. And today the question says, given a non-negative integer x, return the square root of x, rounded down to the nearest integer. The returned integer should be non-negative as well. You must not use any built-in exponent function or operator. For example, do not use PAL-x 0, 0.5 in C++ or x multiplied times 0.5 in Python. So now that we understand what the question is asking, y'all, let's get into the fun part, or not the fun part yet. Let's get into these examples before we get into the fun part. So in example 1, we have the input x equals 4. The output is 2. Explanation says the square root of 4 is 2, so we return 2. So it's pretty self-explanatory, y'all. They give us the input x. In this case, x equals 4, so we want to find the square root of 4. In this case, the square root of 4 is 2, so the output is 2. So let's look at example 2 as well, where the solution, or not the solution, the output will be a double, right? And we're going to have to round, right? So because it says up here, the returned integer should, excuse me, not right here. It says, where does it say? Oh, right here, rounded down to the nearest integer. Return the square root of x rounded down to the nearest integer. So let's look at example 2 where we actually are going to have to round down to the nearest integer, right? So in example 2, we have x equals 8. The output is 2. Explanation says the square root of 8 is 2.82842. And since we rounded down to the nearest integer, 2 is returned. So as you can see, this is important, y'all, because as you can see, normally 2.8 you would round up to 3, but in this case they want us to round it down to 2, and thus that's why the output is 2. So now that we understand the questions and the examples, now we can get into the fun part, the actual solution, y'all. So let's get into it. Now, the first thing we need to do is we need to define the search range. We're going to use a left pointer and a right pointer that starts from x. So in order to do that, we're just going to come right here. We could declare a variable called L and set that equal to 0. Then we can declare another variable called R, and we can set that equal to x. Now we're going to perform a binary search to find the integer square root. So in order to do that, we're going to start our while loop. We're going to say while L is less than or equal to R. We're going to open up our brackets. First thing we need to do is we need to calculate the middle value to avoid a potential overflow. So in order to do that, we can say let mid equal L plus, open up the parentheses, R minus L. Come outside those parentheses, and we're going to divide that by 2. And that's going to help us determine our middle value. Now we need to see if mid squared equals x, that means we found our square root. So we're going to say if mid times mid, which is same as mid squares, is equal to x, then we can open up the brackets and we could just return mid, because that means we found our square root. Now, if mid squared is less than x, we need to move L plus 1, right? So we needed to do that, we could come right here and we could say else if mid times mid is less than x, then what we are going to do is we're going to say L equals mid plus 1. So we're going to move to the right. Else, if mid squared is greater than x, then we need to move R to the left, or minus 1, mid minus 1. So, and search the left half. So in order to do that, we could just come right here and we could say else, open up the brackets, we could say R equals mid minus 1. And we need to decrement mid that way. Now, all we have to do is if the loop ends when L surpasses R, so R is the integer square root of X. So we just need to come right here outside of the while loop and say return R. Just like that, y'all. Now that should be all she wrote, y'all. Should be all she wrote. Let's run it. Make sure it runs properly. And it's accepted, y'all. Look at that. So let's go ahead and submit it. See what that time complexity is looking like. Let's see. Get rid of this. We can get rid of that. And look at that, y'all. 0 milliseconds beats 100% of users with Swift, y'all. That's what I like to see. Y'all already know those are the numbers I like to see. I hope y'all are still continuing down your LeetCode journey with me, because you know we're here every day doing a LeetCode problem until we become the best Swift programmers that we can be, y'all. Don't let anybody tell you what you can or can't do. Don't let that imposter syndrome set in. The imposter syndrome only means something if you give up. If you don't give up, you may have imposter syndrome, but guess what? If you keep going and keep learning, and a couple months from now, a year from now, a couple years from now, you're going to be better than you are now, and people are going to have imposter syndrome when they're comparing themselves to you, y'all. So just keep that in mind. Keep that as some motivation to keep going. And I hope y'all learned something today, and I hope to see y'all here tomorrow for another day, another LeetCode problem. Don't forget to tune in. I'll see y'all then.